So two functions that undo each other are said to be inverse functions. Watch this. Let's throw 25 in this function machine. Turn the crank, we get the output of 47. Input that output as the input of its inverse function, and we get back the original input that we started with. In fact, the same goes both ways. If we take the input of 83, throw it in function g, we get spit out an output of 43. Doing the math, we get 43. Put 43 in the second function, the inverse or undoing function, you get back the original input. So what makes two functions inverse functions, literally? Well, here we have the functions right here. So here we have f of x is 2x minus 3, right? So to show that one function undoes the other, we take the entire function and throw it as the input into its supposed inverse function right there, right? And right here, we take that and we put it as the input right there. Watch this. We take this, we input, we evaluate it, and look at this. Whoop, there we go. 1, 2, 3. And we get back what we started with. The original input is x, because f of x is 2x minus 3. We put that as the input into f, and we get that as the output. We took this entire output, and we threw it as the input right in there. See what I mean? So we got that. And we also have to show it goes true the other way. So we input x into function g right there. So now we're going to take the entire function machine and throw it into the other inverse or undoing function machine right there. And by taking that, we're going to dump that or input it right in there and watch what happens here. We take that. Let's do some algebra there. Oh, 2 divided by 2 is 1. And look at that. X plus 3 minus 3. We get back the identity x right there, the original input. So here we've showed that if two functions are inverses, f of g of x has to be x, as you can see right there, and g of f of x also has to be x, as we see right here.